A rock is dropped from a 20-foot ladder. How long will it take it to reach the ground? That's the question that we want to figure out. Now, in order to do that, we're going to use Newton's theory of projective motion. Here's the equation. Height or time is equal to negative 1/2 g, which is the gravitational pull, times t squared plus v velocity times time plus height. Now, let's look at how we work this through. First, if it's being dropped, then the gravity is going to be 32 feet per second. So we can say 0 here is equal to negative 1/2 times 32 t squared plus the velocity is actually 0, so 0 times anything is going to be 0, plus the height, which we know is 20 feet. Now let's simplify. We have 0 equals negative 1/2 times 32 is negative 16 t squared plus 20. Next, we're going to subtract 20 from each side of this equation. These cancel, and I have negative 20 is equal to negative 16 t squared. T is my time in seconds. That's what I'm solving for. Let's bring that here. Negative 20 is equal to negative 16 t squared. Now I'm going to divide both sides by 16. I'm trying to get t alone. Divide both sides by actually negative 16. These cancel, leaving t squared is equal to negative 20 divided by negative 16 is 1.25. Now I want to get t alone, so I need to cancel this square. I use the opposite of squaring, which is take the square root here, take the square root here. These cancel, leaves t alone. The square root of 1.25 is 1.1. Now, I can have a negative 1.1 as a solution and a positive 1.1. But having negative seconds doesn't make much sense. So I can say that it's going to be 1.1 seconds is going to equal the time it takes if I drop that rock from the top of the 20-foot ladder. Notice that in this step I have used a square root to solve a quadratic equation. Newton's theory is a quadratic equation, and by using square roots I was able to solve it for a time of 1.1 seconds.